We're on lesson 21, question number 5. We're doing rational algebraic equations involving multiplication and division. And we know that when we're multiplying fractions, we look for cancellation opportunities from top to bottom, and we take advantage of all cancellation opportunities, and when those are done, we solve by whatever method we see appropriate to solve by at that point. So, if we're going to look for cancellation opportunities, can you cancel, don't write this down, can you cancel that x with that x? You cannot cancel if there's a plus or minus, right? You can only cancel when it's multiplication. So I needed to say that because somebody's going to try to cancel an x with an x. You can't do it. You can't cancel when there's addition and subtraction. You can only cancel when there's multiplication and division on a fraction, right? So what we recognize then is that this numerator is a binomial and the denominator is a binomial. And we need to rewrite this numerator as the product of its binomial factors, and we need to write this denominator as the product of its binomial factors, so that we have things that are being multiplied so that we can cross-reduce. You can only cross-reduce once it's all multiplication, and to turn it into all multiplication, we factor. Now, on the numerator here, the x squared minus 25, that is what? The difference between two squares, and so we're going to get x plus 5 and x minus 5. We call those binomial conjugates. Very good. So the difference between two squares factors into the binomial conjugates, x plus 5, x minus 5. Everybody recall that from years gone by? Now, remember that if we're going to factor a quadratic and the leading coefficient is 1, we don't really have to go through the AC method. We can just put an x and an x. And then we can think, what can I multiply to get 45 but add to get 14? And the answer is, well, let's look at the factors of 45. 1 times 45, 3 times 15, 5 times 9. What can you multiply to get 45 and add to get 14? So we just put a plus 5 and a plus 9. That's when a is 1. If a was not 1, we'd have to do the whole AC method process. Okay? And so we have rewritten it as the product of its factors. So now everything's being multiplied. So we can take cancellation opportunities from top to bottom with things that are being multiplied. So the x plus 5s cancel. Here the x minus 5s cancel. What we have left is an x plus 7 on top and an x plus 9 on bottom is equal to 11 over 13. Which is a what? Proportion. Right? It's a proportion. And how do you solve a proportion? You cross multiply. Now, we realize that's in parentheses that we're going to distribute, right? So 13 times x is 13x, and 13 times 7 is 91 is equal to, we're going to cross multiply, but we got to remember to distribute. 11 times x is 11x, and 11 times 9 is 99. We said we've gotten to there. So we factored. We found all of our cancellation opportunities. What was left was a proportion that we're going to solve by cross multiplying. Now we know that we need to get the variable we're isolating on one side of the equal sign, remembering to change the sign when you cross over. And so we get 2x plus 91 equal 99. It's time to undo. Whoops. That didn't work. So we get 2x equal 8, divide by 2, and we get x equal 4. Any questions on that? If you plugged it back in up there, you'd find out it works out. Okay? Any questions on number 5? Okay. Number 6. Number 6, what's the operation? Division. We're dividing by a what? Fraction. Is there a rule for that? Yes. To divide by a fraction, you multiply by the reciprocal. Yes, it flips. Now, that rule doesn't apply to the first part or the last part. It applies to the thing you're dividing by. We are dividing by a fraction, and I have that color-coded. To divide by a fraction, you multiply by its reciprocal. Well, everything else stays the same. So the first thing we're going to do is say what is the operation division and what is the rule for that, and we're going to apply the rule for that. Now, the operation is multiplication, and to multiply fractions, we're going to look for all cancellation opportunities, but to have cancellation opportunities, we've got to have things that are being multiplied, and to make it in a form of things that are being multiplied, that means we need to find the factors of each of those numerators and denominators. The numerator of the first one is x squared minus 49, which is the difference between two squares, so it factors into what two binomial conjugates? X plus 7, x minus 7. The denominator of the first one has a leading coefficient of 1. It has an a of 1. That means we can put an x and an x. And then we can think, what can I multiply to get 16 but add to get 8? And if you had to write out those factors, you could do this, right? And you'd say, well, the thing I can multiply to get 16 but add to get 8 is 4 and 4, so it's going to be an x plus 4, x plus 4. So again, that's the shortcut method of factoring if a is 1. Same thing with the numerator of the second one. We can put an x and an x. What can you multiply to get 12 but add to get 7? 3 and 4. We've got a leading coefficient of 1 in the second denominator, so we put our x. What can you multiply to get 21 but add to get 10? 3 and 7. So those are easy to factor because we didn't make ugly coefficients of x squared. Now we're going to look for cancellation opportunities. An x plus 7 here cancels with that x plus 7 there. There's an x plus 3 right here that'll cancel with an x plus 3 right there. There's an x plus 4 here that'll cancel with an x plus 4 there. That's all of the cancellation opportunities. What's left is an x minus 7 on top and an x plus 4 on bottom is equal to 2 over 13. And once again, we're left with a proportion that we can solve. Okay? To solve a proportion, we cross multiply. Don't forget to distribute. 13 times x is 13x. And 13 times 7 is 91. And it had a minus or negative. And then we're going to multiply this way. So we're going to have 2 times x is 2x and 2 times 4 is 8. We need to get the variable we're isolating on one side of the equal sign, remembering to change the sign when you cross over. So we're going to have 11x minus 91 is equal to 8. Now we're going to undo, and so we're going to add 91. We get 11x is equal to 99. Now we're going to undo multiplication by division, and we get x equal 9. So we're solving rational algebraic equations involving addition, subtraction, multiplication, and division. We began with simplifying algebraic expressions involving addition and subtraction. Any questions on lesson 21? All right. Appreciate your attention.